today's topic is actually a very big topic in the industry, which is related to the hardware management, which we call the DC-SCM. It's stands for Data Center Secure Control Module. So I'm going to give you a little bit context and idea to tell you what is a DC-SCM and give you a little bit insight on the 2.0 overview, which is just released not too long ago. And I also want to give you an example of how Lenovo working with our customer Cloudflare to go design and develop a DC-SCM modules. So I have a little sample here, which is a ready product. We just launched it we just published the specification in May, so not too long ago, just 2 months back. And then I'm going to explain to you a little bit about why our customers are doing that and what is their benefit and how does it impact in our industry, in particularly for the server management and security. And then at the end, I give you a little bit update about the 2.1. Is some of the enhancement and improvement based on what has been developed on the 2.0. Finally, I will wrap up with the conclusion and call to action. I hope the content is not going to be too technical, but it's very, very important topics and very big topics in the OCP communities. So first of all, so what is DC-SCM? So when you look at this block diagram, it shows you a traditional two-socket server design. Then you can see the two CPU, you have memory, you have storage, and then you have I/O connected to the left. And then you also have a bunch of the management capabilities connected to the right. So the DC-SCM is to design to go interface with HPM, which stands for the host processor module. So in short, you can imagine the HPM is a motherboard, but the motherboard is focused more around on the compute intensive design. For example, you have user that they want higher CPU, they have more memory centric design, more about the storage or accelerator. So those are the innovation on the compute or the HPM on the motherboard. But on the other hand, is the DC-SCM which is going to take care of the security and also the management capabilities through a connection called the DC-SCI, which stands for Data Center Secure Control Interface. So basically, it allows us to go decouple the BMC and also the root of trust from the traditional server motherboard development cycle, and also allow the customer to improve the security and innovation. And the reason for that is when you look at from a user, from like a hyperscale or CSP user perspective, they are going to have a lot of different server or system or motherboard. They're going to design and fit for their user. And they also, with very important criteria from their sourcing, to source from multiple vendors, and they want to have the interoperabilities across all these different HPM design. And one of the major reasons is the security. And a lot of the customer, they have their own unique security requirement. So it's not so easy to go to get a one-size-fits-all solution. And if you're going to have that security component embedded in the motherboard, it's going to have more lengthy design and validation cycle. And basically, it's adding complexity and adding cost for the development. So the user, they want to decouple those security features, as well as the BMC for the server management to a smaller motherboard. And from a vendor and supplier perspective, you can imagine our company doing server. We're easily talking about like 30 to 50 different type of platforms. So those platforms is going to be generally available for multiple customers. And if each of the customer require customization and go deploy their own security solution, that will be very, very complicated. So from both the buyer side and also the supplier side, we have very strong motivation to go support this decoupling of the security and server management capability through this server hardware management subprojects under OCP, which what the topics I'm covering today under the DC-SCM. And of course, another benefit is support multiple type of architecture. I'm going to explain a little bit in detail, but it doesn't matter whether your CPU is going to be an Intel processor, AMD processor, ARM, or Power. So it's basically DC-SCM can work with all these different architecture, and it support different scale out. Like for example, it support a single socket, 2 socket, and 4 socket system. So you can imagine, so all this complexity can be isolated. And it also allows the customer to go get a cheaper and smaller motherboard. So that helps the cost reduction, that help shorten the time for the development and validation cycle. And of course, the most important is they can also have their own security innovation within this particular SCM secure control modules. So DC-SCM 2.0 is a collaboration of 17 companies. And it's very interesting when you look at those companies, other than the major OCP board member, including Google, Intel, and Microsoft, you find a lot of them, they are server vendor, as well as the semiconductor company. So basically all the major server vendor, they are participating in the DC-SCM subprojects and also contributing directly into this project with their expertise. Similarly, for the semiconductor company as well, because they are all very relevant. So they support the evolving manageability interface and also allow to support multiple use case. And the most common use case is like a single NUC server. And then we're also looking into supporting a multi-NUC server changes in the 2.0 and beyond. So this is one of the very important and major enhancement. Is called the LTPI. LTPI stands for LVDS Tunneling Protocols and Interface. If you're not familiar with that, the LVDS stands for Low Voltage Differentiate Signals. And these are not the latest or the modern, it's more like a conventional interface with a lower speed and throughput that being used in the traditional server design. However, it does occupy more pins out in the system. So you can imagine the LTPI is like a high speed or highway that's going to replace a lot of small narrow roads connecting the cities. So it's a high speed freeway. That means allow you to have a higher throughput and also higher bandwidth with better scalability. So there are a lot of channel being defined under the LTPI interface, like including the GPIO, I2C, UART for debugging, OEM, and data channels. So these are some of the channels that are being defined under the LTPI. And then I would like to talk a little bit about the DC-SCM 2.0 example. There's a project contributed by Lenovo and Cloudflare. Actually, not too long ago, it was published in May, which is a project name called Argus. So a little bit background. Why are we doing this? Because Cloudflare is one of our customers, and they have their own sourcing strategies to buy from multiple vendors. So they are not going to single source. They want to ensure the continuity of supply, driving competition, and also innovations. And of course, that help them to keep their costs down. So their concern is about one of their security, not say vulnerability, but it's a concern on the malware attack at the UEFI layer. They're also very interested to go design on the HPM, which is on the motherboard. So with that, the DC-SCM is a perfect solution to go adjust the security concern and allow them to have a module design for fitting their need. And this is a project for one of their edge computing solution. And we do have DC-SCM modules. It's actually on my hand. As you see, the form factor is very, very small compared to a traditional motherboard with other features. But this board itself is going to focus major on security and the system management. And here is a bit more details. So if you look at that, you can see the interfaces here. And this is what we call the horizontal external form factor, EFF. And this horizontal design is pretty much fit for like an edge system with a very small form factor, like a 1U type of server. And you can see there are a lot of interface that are already built in, including the USB, the UART, which is mainly for the debug purpose. See if I can, yeah, probably cannot show the pointer. But then the USB underneath is a standard USB 2.0. And then you can see the RJ45. We have a mini display port. We also have a button that allows us to do the UID, which is to indicate the location of the device, as well as the power button and showing the LED status of the system. And with this same DC-SCM design, it can actually support multiple platforms. So I mentioned this particular project, or the example that I show is for the edge system. You can put it into a data center deployment. You can put it into other deployments, depending on your HBM design. But they are basically with the standard DC-SCM specification, and also with the DC-SCI interface. So with those standards, that means you can plug any other compatible HBM together with this DC-SCM. And this is a block diagram. It's a little bit detailed, but at the heart of the module is a 8-bit AST2600 BMC SoC. So it loaded with a open BMC firmware and also provide a rich set of common feature that necessary for remote server management. And then the Project Argus also used the AST 1060 as a hardware root of trust. And this is a very important security component, providing a secure firmware authentication, firmware recovery, and firmware update capabilities. The first thing is lattice Mac X03D CPLD with LTPI IP And it supports various of I/O interfaces, including UART and GPIO and SGPIO, etc. So yeah, move on to the next is platform root of trust. Mentioned about the AST 1060. The PFR processor stands for Platform Firmware Resilient Security SoC. It is a security component which intend to protect the platform firmware, particularly on the system BIOS and UEFI. If you remember what I mentioned, the background, why Cloudflare is interested, is because of their concern about of the malware attack at the UEFI level. And this is the key security component going to protect from the malicious attack. And it also allows the hardware platform to meet 3 major criteria, including the protection, detection, and recovery. And then my last section is mainly about the high-level update on the DC-SCM 2.1. With that, I'd like to acknowledge and thanks for the project leads that contributing to this sub-project, including Glenn Hanna from Lenovo. He's our server architect, Ching Wang from Intel, and also Tim Lambert from Dell EMC. There are several of major changes on the 2.1, and one of the, I would say the most significant one is about the bullet number 1. There are going to be 2 different vertical form factor addition. I'm going to show you the picture and how it looks like, which include a short and a long version. And the reason for that is the this is a horizontal. So when you put it a vertical, that means it can go to like a 2U or even a bigger form factor server system. There are also some of the minor addition about the pinouts enhancement, because majority of the pinouts, they have already been used up. So there will be some minor change as well. And also some of the requirement related to the FRU, which is a field replaceable unit. And also the LPTI enhancement, including the minor updates on clarification, including the CRC, UART, latency, and removing SM bus echoes. And then the number 5 is about the improvement to dual NUCs on 1 HBM support. So the dual NUCs on 1 HBM support, that means in future, this DC-SCM is capable with 1 module to go manage multiple server NUCs or multiple motherboards. If you imagine there's like, for example, a 2U system, you can have 2 server NUCs inside, but with only 1 DC-SCM to perform all the security and control. And then the last is to add the SGPIO timing. These are some of the changes in the 2.1. We do have some draft available right now. When later everything is ready, it will be published on the OCP website under these sub-projects. And this is the vertical form factor, the short version. You can see the height is 68.9 millimeters, and then the depth is 199 millimeters. The longer one, with the same height, but is deeper, go up to 259 millimeters. The deeper version allows more capabilities and more innovations. That means customer can add more features onto this deeper or the longer version of the vertical form factor DC-SCM board. Finally, the conclusion and call to action. First of all, we'd like to encourage to minimize the DC-SCM SKU and maximize the HPM leverage and we use. For example, some of the hyperscaler customer already said the DC-SCM, they're going to have this and then going to support multiple generations of the CPU technologies into their data center. That means for the next 2 to 3 generations, they're not going to change this, but they're going to changing on the motherboard side on the compute. Second is to continually evaluate evolving interface, voltage, HPM use cases. I think this is going to be very, very important for us to continue to improve on the projects and enhance. However, the form factor should not be changing too much. I think those should be pretty much standard for a longer period of time without keep changing the DC-SCM form factors and pins out. And I also like to encourage, if you are interested, please participate in the hardware management projects. The DC-SCM is one of the sub-projects. We do have a regular meeting at the beginning of the month so that you are encouraged to join and participate. And of course, you can also subscribe to the mailing list. Then you can get the update. And there are a lot of information that published on the website that I have the link here. So if you're interested, you can definitely feel free to go have a look. With that, that's the update about the DC-SCM. It's going to be very important for both the buyer side as well as the supplier side. And thank you very much for everyone staying late in the session. I appreciate that. Thank you.